All right, and here we go with problem number 7, which is a definite integral. So let's see what we have to do here. So generally whenever I see like a cosine of something, I assume that that something is going to be the u. So let's make our u pi x over 2. Remember, pi is just a number. So really when you see a fraction like this, you can think of it as pi over 2 being multiplied by x. It would be x over 1, and you multiply straight across. So really, pi over 2 is the coefficient of x. So if pi over 2 is the coefficient of x, when you take the derivative of that, you're just left with that number, right? If, for example, you were to take the derivative of 3x, the derivative would just be 3. So when you take the derivative, it's just the number. So it's just the coefficient of x here, pi over 2. There is no pi over 2 here in the problem, but that's okay. If we need to multiply by 1, we could divide by pi over 2, or remember, you could multiply by the reciprocal. So like pi over 2 times 2 over pi is going to equal 1. So if I multiply something by pi over 2, I also have to multiply by 2 over pi, so that I'm still just multiplying by 1. So again, when you think about, in other problems we'd multiply by 3 and 1/3. The reason we do that is because they're reciprocals. So if one of them is a fraction, multiply by the reciprocal to get the other one. So that means my next line is going to be, I have a 2 over pi outside the integral, cosine. And then I'm just going to write it all out for a moment. Okay, so what I have here is I multiplied by 2 over pi and pi over 2, because that equals 1. And then pi over 2 dx, we can see, is equal to du. So now we can use our u substitution. Okay, 0 to, we'll say, x equals 0 to x equals 1 for now. Because we're going to have cosine u du, but I know that these two things are not what I'm going to plug in for u. All right. Let's see what happens if we plugged in 0 and 1 for u, so that we can do our definite integral. So if u equals pi x over 2, and we let x equal 0, then u would equal 0, since anything times 0 is 0. And if x equals 1, pi over 2 times 1 would be pi over 2. So we can actually change these now, as we were supposed to go from, instead of 0 to 1 for x, u is going to go from 0 to pi over 2. Cool. Okay. All right. Then we will finally be ready to take the integral. The integral of cosine is sine. So we have 2 over pi times the sine of u. And again, we're going to do that from 0 to pi over 2. And that's because we are plugging into u, not plugging in for x. All right, so when I plug in 0, I have 2 over pi times the sine of 0 minus 2 over pi times, pi over 2 comes first. Pi over 2 minus sine of 0. So I have 2 over pi times the sine of pi over 2 minus 2 over pi times the sine of 0. Now, the sine of pi over 2, I always draw myself a quick unit circle over here. Pi over 2 is here. The y value is 1, so the sine of pi over 2 is 1. So we'll be left with 2 over pi times 1. And the sine of 0, which is right here, is just 0, and anything times 0 is 0. So that's going to be 0. And 2 over pi times 1 is 2 over pi. So the solution is 2 over pi.